Today we're looking at a problem from 2009. I classified it as both type 1 and type 2 because we are talking about rate and accumulation. That makes it a type 1, but we also have a lot of questions regarding position, velocity, and acceleration, so it kind of falls in the category of both type 1 and type 2, making it a really good problem. So part A says, find the acceleration of Saren's bicycle at time 7.5. So we're looking for the acceleration, and we should know that the derivative of velocity is the same thing as acceleration. And since they provide us with a graph of velocity, we need only calculate the slope of the graph at 7.5. So when we look at the graph at 7.5, we see there is a slope, it's a straight line, and the slope, some people might be inclined to say the slope is -1, but if you look closely, the scaling on the left-hand side is by 0.1s, so it's down 0.1, right 1, so it's -0. Oops, let's not write that there. A of 7.5 is going to be, we'll do the approximator, v of 8 minus v of 7 over 8 minus 7. That's how we show our work, and we get an answer of -0.1. We have to indicate units of measure. It says indicate units of measure. So in acceleration, we have meters per second squared or miles per hour squared. We have to look at the units that the problem consists of. Our road is being measured in miles. There we go, miles. And our time is being measured in minutes, so this is going to be miles per minute squared. This is worth 2 points. 1 point for the answer. Keep in mind you have to show the work that leads to that answer, and then 1 point for the unit. Moving on to part B, using correct units, explain the meaning of the integral 0 to 12 of the absolute value v of t in terms of Saren's trip. So the integral of an absolute value gives us the total distance that Saren traveled, and we have to be specific, from t equals 0 to t equals 12 minutes. Okay. If the absolute value was missing, it would give us total displacement. But with the absolute value, it's the total distance traveled. So Saren has traveled towards school with a positive velocity, and then she turned around and traveled back towards home, and then she spent a minute looking for her calculus homework, and then she traveled back towards school over time. So her total distance includes some forward and backward travel. And they ask us to calculate what is that total distance. And so this is a calculation of an integral using whatever approach you want to take. If you want to add up a bunch of triangles, if you want to count squares, I do know that this triangle right here is 1 by 2, and then you cut that in half, so this is 1 square of space. So I like counting it as squares, but you just have to remember that the area of each square of space is 1 by 0.1. So in the first interval from 0 to 2, she travels 0.2 units. From 2 to 4, she travels 0.2 units. And then in this final stretch, she travels 1.4 units. So either calculate it using geometry or count up the squares. But Saren traveled 1.8 miles, which means she lives closer than 1.8 miles because she went forward to school and then backwards to home and then forward to school. In fact, if you ignore the fact that she had to do a turnaround point, you could say that she lives 1.4 miles from school, because from home to school was a total of 1.4. So That's part B. Part B is worth 2 points. The first point comes from the meaning, and in order for you to get the full credit of the meaning, you have to remember to include the interval. You can't just say total distance. So include the interval 0 to 12. And that's worth 1 point. Then the second point comes from what is the value of that integral. 1 point there. So. On to part C. Shortly after leaving home, Saren realizes that she left her calculus homework at home and she returns home to get it. At what time does she turn around to go back home? So, we discussed this when talking about part B. V of t changes positive to negative at t equals 2. So that means she was traveling forward or away from her home, and then she was traveling backward, which is towards her home. So Saren turns around at this time. At time t equals 2 minutes. This is worth 2 points. Your first point comes from, can you identify the time that she turns around? And then your second point comes from the justification. Larry also rides his bicycle along a straight road from home to school. His velocity is modeled as W of t, where W of t is miles per minute from 0 to 12. Who lives closer? If we integrate from 0 to 12 W of t, we're integrating a rate function, and this will give us his total displacement, or his distance from school. Turning to a calculator and typing this in, we get a value of 1.6, not approximately, it is equal to 1.6. So Larry lives 1.6 miles. Larry, 1.6. It's Larry. Okay. Larry lives 1.6 miles from school. 0 to 12 of v of t, we found from above, is 1.4. We have to ignore that forward and backwards chunk. So Saren lives 1.4 miles. So Saren lives closer. Therefore, Saren is closer. This is worth 3 points. 1 point for Larry's distance, 1 point for Saren's distance. Sorry, this should have been 2 points. 2 points and 1 point. Okay. Ask good questions, conquer the world.